Okay, I've done a rough sketch here, and now I need to decide what information is provided to me. So I was told that angle C is 40 degrees, side A is 8, and side C is 20. A couple things to notice. Notice how C is much longer than A. That means that angle A must be much smaller than angle C. So this may not be drawn exactly to scale, but it's important we are aware of this. Okay, we have, if I do going around in a clockwise position, I have a side and an angle. Remember, whenever we have SSA, side, angle, we always have the possibility of having no triangle, or if a triangle exists, there could be one or even potentially two. So let's get started here. Let's go ahead and let's figure out what is angle A. So I'm going to do sine of 40 degrees over 20 equals sine of angle A over 8. Okay, so I would cross multiply here to get 8 sine of 40 divided by 20 equals the sine of A. If I went and did all the work there. I'm in degrees, and so I'm going to go 8 sine of 40 degrees, and then I'm going to divide by 20. Okay, what does this tell me? Because the sine value equals something that is between -1 to 1, it tells me that I will have a triangle. Now, there could be two triangles, but there definitely would be one. So once again, SSA, when you have two sides and an angle that's opposite of one of the sides, you have the possibility of no triangle, one triangle, or even of two unique triangles. I know at least one triangle exists because the sine is between -1 to 1. Let's keep going here. I'm going to go second sine, and I'm going to put that right in. Oops, sorry, here. I'm going to copy and paste that in, and we have right now that angle A is approximately 14 point, okay, that would bump up, and that would bump up 90. Now, this is the case when A is going to be an acute. So acute, again, is going to be less than 90. But as we spoke about in example number 4, we always need to take into account that if I draw this picture, so here's where the sine is approximately 14.9, but the sine would give you the same value over here because sines are positive on top with this reference angle. So if I take 180 and I subtract that exact amount, I'd get 165.10. So I also need to be aware that potentially I make the exact same triangle and I have angle A be at 165.1. We need to keep that in mind. So let's first go ahead and let's fill out this given information. Okay, well, how do I figure out angle B? Angle B, well, I know this is 14.9, and so I'm going to take 40 plus 14.9, and I'm going to subtract that from 180, and we can see I end up with 125.1. 125.1 degrees. 125.1 degrees is the key here. Got it. Okay, so then I'm going to take what's not rounded. So this is rounded. I want to take the exact information. So the sine of 40 over 20 equals the sine of 125.1 over B. I'm going to cross multiply and have B times the sine of 40 equals 20 times the sine of 125.1. When I divide by the sine of 40, I've isolated B. Let's figure it out. So 20 sine of 125.1, get an answer, and then divide by the sine of 40. All right, so 25.46. 25.46, I've had to round, and so I want to make that. Okay, so I know at least one triangle exists, and this is it. Excuse me. Now let me fold this up, and let's now check for two triangles. So I'm going to go ahead and write A, B, and C, little a, little b, and little c. Now what do we know? We were told that across from A is 8 and across from C was 20, and we were told that C is 40 degrees. Now, as we just spoke about, sines are positive in quadrants 1 and 4, so the sine of 165.1 will be the exact same answer as the sine of 14.9. And so I'm going to go ahead and I'm now going to check 165.1. So I'm saying that I think A potentially could be 165.10. So just like we were able to solve the missing pieces of this triangle, let's go ahead and let's add this together. We have 165.10. Give me 1 second. I'm sorry, I have such a cold. So 165.10, to figure out that missing angle B, I'm going to add 40 to it. and I get 205, and normally I would say, well, subtract that from 180. The problem is, I've already surpassed 180. That means that it's not even possible, right? There'd be no degrees left. These three have to add up to 180. It's not possible. So the second triangle is not possible, and for that reason, we would say that this particular problem only has one unique triangle.